In this video, we're going to talk about the high-level concept of resolution 9.4. So in order to resolve means to see two objects as optically distinct. In order for happen, something called the Rayleigh criterion has to take place, which means that in order to just resolve the two objects, the maximum of the first object has to fall on or after the first minimum of the other. So here we have the intensity angle pattern for two distinct objects which have been diffracted through the same single slit or aperture, and you see here that the single slit pattern of the red is very close to, or the two maxima for the red and the blue are very close. Therefore in this situation we say they are not resolved. However, down here, when the objects maybe have got a little bit further apart, we say they're just resolved because the maximum of one falls on the minimum of the other, and likewise the maximum of the other falls on the minimum of the first one. So we say that the angular separation of the objects, theta A, has to be greater than or equal to the angle of the diffraction minimum of the second. And the diffraction angle for rectangular slits is the same one we used previously. It's lambda over b for rectangular slits. But for circular apertures or circular openings, the diffraction equation changes to be 1.22 lambda divided by d, where d is the diameter of the aperture. Now, when we're observing gases which have emission spectra or absorption spectra which are very close together, we have to have what's called a high resolving power in order to see that very small difference in wavelength. And for the sodium's double line, the difference in the wavelength is 1/2 nanometer, which is very small. So what happens is the light from sodium comes to the diffraction grating. A lot of the light gets passed straight through, and that's the central maximum. We won't resolve the two lines. But as we move away from the central maximum, at the first order, we might not resolve the two lines, but maybe in the second order, at m equals 2, we see the two lines of sodium maybe as being resolved. In that case, we have been able to resolve the two lines. And you can use the resolving power formula, R, where R is resolving power, lambda is the average wavelength of the lines, delta lambda is the difference between the wavelengths that you want to observe, m is the order at which you observe them, and big N here is the number of slits being illuminated by the source, not the total number of slits on the diffraction grating, only the number that are illuminated by the beam from the source.